You think you're so smart. Well, prove it.
Hello, everyone. Today we're going to talk about the notion of truth versus the notion of provability. I have a student who wants me to talk about and help him talk about a speech directed at fourth graders, but one that is far reaching in the world of mathematics and science. And today we're going to talk about Gödel's incompleteness theorem. You might say, blah, mathematics, theorems. Well, sit back and relax because we're going to talk about something that has really far reaching implications, not just to mathematics, but what computers can do and potentially what we can do. So let's get into it. Kurt Gödel was a brilliant mathematician, probably one of the greatest of all times. And I would be doing him a disservice if I could claim that I could even do a fraction of explaining what he can explain. But again, I have this task to share it with a young person, and they have the task of being able to reach other students without any mathematical background. So here we go. Let's give it a shot. Kurt Gödel was a genius. And like all geniuses, had a way of explaining things that were really, really mind-blowing into a simple explanation. And if we want to be effective as people, we have to do the same thing. So let's try it right now. Gödel said the notion of truth is greater than the notion of provability. And you know what? I'm going to give you a simple proof. He said, imagine that we could create something called a universal truth machine. A machine that was able to decide whether or not any statement was true or false. Hey, give us a million years, give us a billion years, give us a trillion years. It doesn't matter. Because Gödel said, if you give me the blueprints, you give me the programming, if you give me the circuitry, I'll write a statement. He said, the universal truth machine, defined by your software and your circuitry, will never say that this statement is true. Imagine we have a machine so powerful. It can say true or false and determine whether something is true or false. But what would it say to this statement? Now imagine you are this machine. What would you say? Could you say that this is true? You can't. Because if you just said that this is true, you've just contradicted yourself. You just told a lie. The statement says you'll never say this is true, and you said it's true. So you can't say it's true. But can you say it's false? You can't. Because if this statement is false, what does it mean? That means that the universal truth machine will sometimes say that this statement is true. And when it does, it's a lie. So what can this all-powerful universal truth machine say? But you know what is true, even though you can't prove it. And so, Gödel pats himself in the back with a brilliant idea because he's shown that there are some things in a system, maybe even our system, that are true but cannot be proven. And this has far-reaching implications to our language, to what our computers might be able to do, even to what we can do and what we can say about the very foundations of our logic and maybe even our universe. And you might think that this is a very contrived, contained example, but you know that Godel was able to extend this to so many other areas. In fact, he did it into the realm of even arithmetic. I mean, we all take for granted that 1 plus 1 is 2, or 2 equals 2, but this relies on underlying axioms, what we call guesses or assumptions about what is true. Like, what does equal mean? What's equality? But if we have to prove that, we need to pull something else in because our system is not complete. Maybe you have to pull in the idea of zero, of nullity, or maybe we have to pull in the idea of unity or some other idea. But if we do that and pull in some other ideas, then we have to prove that. And then we have to if we want to prove this idea of nullity, maybe we need to pull in more ideas. And so the system is incomplete. And that is a really mind-blowing concept about what we can know and maybe what we can even prove. So I leave you with that.
You think you're so smart. Well, prove it.
The next time someone asks you to do that, maybe you can point to the limits of the UTM. So hopefully that's been some food for thought, and I hope that you found this useful. And like my student, that you would use it to extend and share knowledge with the rest of the world. So once again, I'm Jeremy, and have a great day. That's the truth.